right, advanced 7th graders, glad to have you here today. Today I'm going to teach you how to solve more advanced problems involving parallel lines and a transversal. So you know what to do. Open a math notebook, make this the title. When you've done that, close it up. And this is a biggie, so be ready. So yesterday we looked at situations like this. We looked at two parallel lines. Remember, parallel means no matter how far they extended on forever and ever, they would never meet. They kind of follow exactly the same path. They'll never intersect no matter how far you were to go. And we learned a few things about their, well, before that, we also called this a line kind of cutting between two parallel lines, a transversal. Fancy word. So there's another line that cuts through them. And when we have two parallel lines cut by a transversal, we learned some things about their angles. We learned a bunch of different types of angles, names. Most of them are not that important, but a few are. First of all, we've of course, with just one of these, we've got vertical angles. And those match. They're across any intersection. So those are vertical, those are vertical, these are vertical, those are vertical. We have lots of those. Those are called vertical angles. But we also learned yesterday that since these lines are parallel, all the angles here match all the angles here because the two lines are parallel and the same transversal cuts them. So from that standpoint, we figured out if we know this angle, then we know this angle. Those are called corresponding angles. And then we also learned similarly here, if we know this angle, then we know this angle. They match because they have the same parallel line cut by that transversal. Those are corresponding angles, and so on. If we know this one, we know this one. So that's another way to find angles we don't know the measurements of. I do want to mention it's important this only works if the lines are parallel, like these are. Two parallel and a transversal. If the two lines being cut by the transversal are not parallel, like you'll notice these two are not, then that doesn't work. The corresponding angle thing doesn't work if the lines are not parallel that the transversal cuts. And you can pretty much tell that by looking, like this angle here doesn't match this angle here because these lines aren't parallel. If we extended these far enough, eventually they would intersect down below. So they're not parallel, so that corresponding angles thing only works if they're parallel. All right, so let's look at a doozy here. We're going to look at some real tough ones today. Use the figure below to answer the following questions. A and B are parallel lines here. And of course, they have a transversal through them. And just to make this extra fun, we've got some other extra lines coming from there too. So a lot of stuff here, and you'll notice we're asked to find a lot of different angles. We do have what we need, more or less, to do that. So we're going to begin. So as I look, I'm only given really one angle. I'm only given this, I'm going to switch colors. I'm only given this 35-degree angle right here. I believe that's the only measurement in the whole thing that I'm given. I guess I can see some 90s too. That's true. I can also see some 90-degree angles as well. So I've got to use just that little information to find all of the rest of these. So angle 10, I'm going to start there. That's an easy one. It's marked for me. I'm told that angle 10 is a 90-degree angle, so that was easy. I'm also told that angle 5 is a 90-degree angle. So I can go ahead and write that in too. So good start, easy stuff. What next? I have to look around and say, well, what am I absolutely sure that I know the measurement of? And I think the next easiest thing for me to find is number 1 here. Because if I look at number 1, I can tell that it is supplementary with all of these. So 35 plus 90 plus whatever 1 is. I'm going to have a lot of mess here. 35 plus 90 plus whatever angle 1 is are all going to add up to 180 degrees. So 180 minus the 90 would be 90, minus 30 would be 60, minus 5 would be 55. So angle 1 is 55 degrees, and I use supplementary angle reasoning to figure that out. We'll do some erasing. I'm going to end up real sloppy here if I keep everything I want to do there. So angle 1 we have discovered 55 degrees. What next? I would probably next go to this one because I can tell that angle 1, which I found, and this angle with this algebraic expression, they also make a straight angle. They should be supplementary as well. So I know that 55 from this angle plus 4x plus 1 from this angle, those should also add up to 180 degrees. And I can figure out what x is next from there, and I'll also know this angle. So knowing that, let's see that. I'm going to combine like terms. And now I've got a quick equation to solve. Subtract 56, subtract 56. 180 minus 56 is 4. 17 minus 5 is 12. 124. So I'm left with 4x equals 124. Divide both sides by 4. And x equals, what? 100 divided by 4 is 25. 24 divided by 4 is 6. So 25 and 6, I think it's 31. So x is 31. I still, I guess I wasn't asked for that angle, so I won't worry about it quite yet. Last, I can use that to figure out angle 8, or I can actually look, if you're careful, and check angle 8 is vertical to the 55 degree angle. So it's also going to be a 55 degree angle. All right, that takes care of all my top ones, but what about the bottom? I don't have any of the angles at the bottom given to me, none, not a single one to start, I guess other than the 90. And even that 90 is not going to help me a ton because I don't have anything really matched up with it to make a full set. But remember, anywhere, if we've got the same parallel lines cut by the same transversal, we're going to have some corresponding angles in this bottom set. For instance, I think you can tell this E and this C mess things up, but I think you can tell angle 6 and angle 8 are corresponding angles. They are the same measurement because they only involve the parallel lines and the transversal. They don't involve this extra stuff. So that's how I'm going to get my first clue down bottom, is I'm going to use these corresponding angles and say, well, angle 6 is equal to angle 8, and angle 8 was 55 degrees. So I know that, even though it wasn't given to me. I think 3 is also a corresponding angle. Well, I can do that a few ways. 3 is going to match this 55 because they're in the same position. They are corresponding. So I can also say 3 is 55. I also could have known that because it's vertical from 6 across the intersection as well. So now I'm really getting somewhere. Now I know down here I've got these two 55s and this 90, all thanks to corresponding. That's how I got from the top to the bottom. And then I could follow a similar process to find these other ones here. For the sake of time, I'm just going to go ahead. You can find supplementary angles here and supplementary angles here and finish the job. All right, let's try another challenging one together. Open up your math notebook. I'll give you time to write this one down and copy the diagram and unpause when you're ready to go. Okay, so one more time. As always on We Do, if you think you can do this, it's like a puzzle to undo. Without my help, go for it. And then you can just unpause and see how I do it and see if your answers match. If you'd rather work along with me, let me do a little bit, pause, write it down. Let me do a little bit, pause, write it down. That's fine too. So we're going to find all these, even though we're only given one of them, nothing else. And it's going to go great. We can do it. So right off the bat, I'm going to go to 3 first. I can see these two lines are parallel and they have a transversal. So I made a vertical angle here. 3 is vertical to the 72. So that one is quick to find out. Let's see. I could do either the variable one or the 4 next. Let's go to the 4. It's probably less intimidating. 3 and 4 together are supplementary. They make a straight angle. So 72 from the plus 4, or whatever 4 is, 72 plus this missing angle for 4 should make 180. That I believe is 108. Plus 2 is 110 plus 7, yeah. So that is that. So now I'm going to do some erasing so that it's not too sloppy for you here. So now we're almost done with this whole first set. I've got 72, 72, 108. That says 180, sorry. There's a couple different ways we could find this one. We could use its vertical angle to find this one, or we could use a supplementary angle to find this one. It's not going to matter which way we do it. I'll choose the vertical. So I know that whatever this is, 5m minus 3, I know that when I'm done, it's equal to a 108-degree angle. I would solve that equation by adding 3 to both sides. And now dividing both sides by 5. And I'll take a calculator for that since it's not going to come out even. I think I know what it is, but I'll double check. 111 divided by 5, 22 and 2/10 is m. Now remember, that doesn't mean that's a 22-degree angle. It means m is 22. We already know the measurement of that whole angle has to be 108 because it's vertical from here. That's an easy thing to confuse. So that's all the stuff here, but look at this. Here we don't have anything. Like absolutely nothing is given to us on that side, except in a way, all of it's already given to us because we've already done the legwork on the right. If you look at it carefully, since we've got parallel lines, 1 is corresponding to 3, 2 is corresponding to 4, 5 is corresponding to this, 6 is corresponding to this. We actually know all of them just thanks to corresponding angles. So 1's going to be equal to 3, 2 is going to be equal to 4, or in geometry we say congruent. 5 is going to be congruent to this one, which was 108, and 6 is going to be congruent to 72. And so what's kind of nice is it's a lot less work than it seems like it's going to be. You have to find all the angles on one side oftentimes, but then you can kind of look and say, oh, check it out, like all of these correspond. And it's not as tough as I thought. So y'all, I hope that makes some sense. That's how you use corresponding angles to solve problems involving parallel lines in a transversal. If this seemed logical as you saw me do it, you're probably in good shape for class tomorrow. If not, give it another watch, and I think you'll come to class tomorrow feeling super confident and super ready. Thanks for your attention, and I'll see you tomorrow.